Hi, this video we're going to look at an example that has a concept of specific heat. And it said a frictionless piston cylinder device, also a rigid tank, contains 3 kilomole of ideal gas at the same temperature, same pressure and volume. Now heat is transferred, so we have, a piston versus a rigid container. They all have 3 kilomole of ideal gas. So we don't know what that is, right? And then they all raise up to 10 degrees Celsius. There's heat coming here and there's heat coming. That's Q1, Q2. Actually, I'm going to use so this is at constant pressure and this one is constant volume. So the amount of extra heat that's required maintaining a constant pressure, we know Q1 is going to be greater than Q2 because not only heat is added to raise up 10 degrees Celsius, but it also is used up to raise up this piston up, right, to maintain that constant pressure. So also we have come up this relationship Cp is greater than Cv, and Cp is how much greater than Cv? It's this gas constant. And here are Cp, Cv, they all have the unit of kilojoule per kilogram per Kelvin or per degree Celsius. That's exchangeable because it's a change in temperature. But here they're using kilomole, right? And so if we are going to divide this by molar mass, which is going to be have a unit of kilogram per kilomole. So if we were dividing that, or actually for this situation we are going to times, we're going to times molar mass, because then kilogram cancel, they were going to get kilomole. And the molar mass is going to be the same for the same substance. So here we're going to get our Cp with a bar. That will have a unit of kilojoule per kilomole now, then per Kelvin, okay? And then that's going to be equal to Cv bar, have the same unit. And here R is going to become Ru, right? Because they also, Ru has a unit of kilojoule per kilomole per Kelvin. And we know Ru being a universal gas constant, and Ru here is equal to 8.314, right? Kilojoule per, here's kilojoule, mistake. Kilojoule per kilomole and per Kelvin, or per degree Celsius, that's the same, okay? So knowing that, we're going to figure out the heat, how much extra heat required, right? So knowing that extra heat is resulting from this Ru, because that extra work is going to be from the Ru, okay? So if we were trying to times the same amount of kilomoles, and if we were trying to same amount of degrees Celsius or Kelvin, then that's basically give us how many kilojoule, how many extra kilojoule. And in that situation, Cp, the extra work, the extra energy, it's going to be with this between the constant pressure and the constant volume. Pressure and volume, it lies on Ru. So we're going to use Ru, which is 8.314 kilojoule per kilomole per Kelvin. And then we have how many kilomole? 3 kilomole. And then we have raised by 10 degrees Celsius. Again, this 10 degrees Celsius can be write down as 10 Kelvin, right? So calculate that. Let's see what we have. 8.314 times 30. Then we get answer as 249 kilojoule. That's going to be the extra work, 249 kilojoule. All right, so this is a quick example to show Cp is greater than Cv and how much greater than R. And we can manipulate using molar mass to change to universal gas constant. That tells us how much extra energy is required if you are heating up the substance in the constant pressure compared to constant volume. So that's all for this problem. I'll see you next time. Bye.